Hi students. So in the last class we completed the rate analysis. So how to calculate the rate analysis for cement concrete. Now today's class is how to calculate the rate analysis of RCC works. How to calculate the rate analysis for RCC works. So RCC works involves beams, columns, slabs, foundations, etc. These are all includes an RCC works. So now how to calculate the rate analysis for these RCC works in beams, RCC works in columns, RCC works in slabs, whatever it may be. Okay. So before going to calculate the problem, now let me some introduction about this class. Okay. So generally the materials when it comes to the RCC works. So RCC stands for reinforced cement concrete. I think everyone know about this. So along with cement, coarse aggregate, fine aggregate, so on so water, whatever it may be. Along with this, steel is going to be added for additional. Am I right? RCC. So R stands for reinforced, so that it includes a reinforcement. The steel extra we have to calculate the material calculation. Okay, how much quantity of steel is required for the beams, for columns, for slabs, whatever it may be. So we have to finalize the quantity of steel. So remaining cement, coarse aggregate, fine aggregates, remaining is same, similar to the previous calculation also. Okay, so we'll go to the one more point we have to keep it in mind as per the IS standards. So when it comes to the beams, the percentage of steel as per IS 456 percentage of steel, so it will be in between 1 to 2%. Okay, and coming to the columns, the percentage in between 1 to 5%. Similar, frequently we have to consider the 2.5%. Okay, and next one for foundations. So foundations or footings, whatever it may be, footings, it will be equals to the 0.5 to 0.87 percentage. So this is the percentage of steel in beams, in columns, and this is in footings, foundations, and foundations and slabs. Here it is a slabs. Okay, there are some important points before going to calculate the rate analysis of RCC works. These are all standards. These are the standards, so which already derived in the IS 456 standards. Okay, now let it be the standard quantity of a steel. We'll discuss. So density of steel is very important. Density of steel is equals to, this is the standard point, 7850 kg per meter cubic. This is the standard. Per 1 cubic meter, the density of steel is 7850 kgs. Okay, and we already defined 1 cubic meter, the cement is 1440 kgs. Like that, for steel also, per 1 meter cubic it is 7850 kg per meter cubic. Let it be actually in market the rate, it is not as kgs. So in the market it's always we have to take as a quintal. In the market the rate of steel is in quintal, so that we have to convert this one as in quintal. Okay, per meter cubic how many quintal of steel is there, means it is equals to 78.50 quintal. It means 1 quintal is equals to 100 kgs. Okay, so that density of steel, this is in kgs and this is in quintals. So I think everyone clear about the how to calculate, I mean standard formats or standards density for steel and percentage which already derived from the IS codes. Clear about the, I think everyone clear about this. So one is beams, and this is the 1 to 2% we have to consider, and the columns is 1 to 5%. Frequently we have considered only 2.5%, and footings and slabs are 0.5 to 0.87. Okay, now we'll move to the calculation of RCC main problem. Okay, I'll write the problem here. RCC works or RCC work in beams. RCC work in beams with 1 is to, sorry, with yeah, with 1 is to 2 is to 4. Sorry for inconvenience. Yeah, yes, 1 is to 2 is to 4. RCC works in beams with 1 is to 2 is to 4 mixed proportion. So unit is, we need to calculate 1 cubic meter. So let, starting itself in the previous problems, a number of times I explained, first we have to consider the take unit 10 cubic meter. Okay, now the proportion is 1 is to 2 is to 4. So first of all I am going to calculate the quantities. So I already explained about the dry volumes, all those things. Directly I am going to that. I'm not explaining all those things. Directly I am going to calculate the quantities of cement. So the quantity of cement, so is equals to, so 1 is to 2 is to 4, this is 1 is to 2 is to 4 proportion, so that cement is 1 divided by 1 plus 2 plus 4, product of, we are taking 10 cubic meter as the unit, but we have to consider extra 50 to 60%. I already explained, that is dry volume. So 15.4, it will be equals to 2.20 meter cubic. This is the quantity of cement. Next one, quantity of sand. So quantity of sand is 2.20 be the cement, product with 2. Here the 1 stands for cement and 2 stands for fine aggregate and 4 stands for the coarse aggregate. I am writing as a quantity of sand. So it will be equals to 4.40 meter cubic. And the last quantity is quantity of coarse aggregate. So this is coarse aggregate. I am considering 20 mm ballast, that is 20 mm aggregate. So it will be equals to 2.20. So 2.20 into coarse aggregate proportion is 4 and this value is 8.80 meter cubic. So when you when you summing of these quantities, that is 8.80 plus 4.40 plus 2.20, it will be is equals to the 15.4. So you try once, automatically it will come 15.4 cubic meter, 8.80 plus 4.40 and 2.20. These are the quantity calculations. Okay, now we'll move to the how to calculate the quantity of steel. So in the starting I explained the standard standard parameter quantity of steel for 1 cubic meter in kgs. I already explained. So now we have to consider quantity of steel. Now we are calculating here the beam. So quantity of steel for beam per 1 meter cubic I am considering 1%. So this is for 1 cubic meter I am considering. So in the standards I already explained 1 to 2% be the beam. Now I am considering 1% as a quantity. Am I right? For 1 meter cubic, you listen carefully, for 1 meter cubic in quintal it is 78.5 quintal. Am I right? But here in the problem we have taken the unit 10 cubic meter. Am I right? 10 cubic meter is equals to, for 10 cubic meter it is 785 quintal. Am I right? So 78.5 into 10 divided by 1, it will be is equals to 785 quintal. Okay, now here I am considering the quantity as 1%, so that so final quantity, that is quantity of steel is equals to 1%, means 1 by 100 into 785 quintal. It must be is equals to 7.85 quintal for beam. Okay, again I am repeating. So how to calculate the quantity of steel? Okay, so listen carefully. Quantity of steel for beam I am considering as 1% for 1 cubic meter. So the standard format, that is 1 cubic meter quantity of steel is 78.5 quintal. In quintal it is. In the problem we are consider the unit, or we are taking the unit as 10 cubic meter. For 10 cubic meter it is 785 quintal. Okay, now we are calculating for this problem quantity of steel 1% we are considering, so that 1 by 100 into, for 10 cubic meter it is 785 quintal, and it will be is equals to 7.585 quintal for this particular problem. Okay, now we'll go to the standard format. So in the one is item number, and the second one particular of item, and the next one is quantity, and the next one rate, and the last one, this is the cost. And this is the standard format, everyone knows. So before going to start this one, quantity calculation or rate calculation, so we already finalized the quantity. Okay, and there is very important concept is labors. Okay, so standard labors are types of labors we already discussed: head machine, and next one mazdoor, and the next one is boy or woman coolie, and the next one bisti. These are the standards of labors, but count is very important. Head machine is always half number, he spends half day in this work, and the machine 2 to 3%, 2 to 3 numbers, and mazdoor 10 to 12 numbers, required for this work, and the boy or woman coolie 20 numbers required for this case, and the bistis are 6 numbers. Why? Because this is an RCC work. So these are the standard labors for RCC works. So this is an approximation. So this much of labors are required for this particular work. Is this enough? We'll finish the work by using these labors. For RCC work I am saying no, it is not enough. Why? Because along with this still some particular labors will be required. What are the, who are they? Now we'll discuss now. Along with this, for it is an RCC, bending of steel, bending and cranking and binding of weights, separate labors will be required. So we can call it as that labor name, call it as blacksmith. We can call it as a blacksmith. And next one, for helping blacksmith, mazdoor will be required. So blacksmith, how many 8 numbers will be required for this RCC work, and for this also 8 numbers required. And along with this, is this enough? So normal labors for constructing and bending and cranking or binding the wires, whatever it may be, these 2 labors are required. Is there any labors are there to complete this work? Yes, shutterings. Again, centering works, shuttering works, centering and shuttering, centering and shuttering. Separate labors will be required. One is main material is timber planks are required. Am I right? For sectoring, timber planks. Now we can consider as a lump sum cost here. And the second one is for centering and shuttering, there is a carpenter. There is a carpenter required, and we can call it as a second class carpenter. Here also blacksmith is, as per standard I am saying, here also second class blacksmith is there, and along with carpenter one, I mean mazdoor is also there for helping. Now when it comes to the carpenter, how many carpenters are required for this work? 10 numbers, and mazdoor also 10 numbers. These are the extra different labors for this particular RCC works. Okay, so this is head machine. Is these are, I think you already know, head machine, machines, mazdoor, boy and bisti. Along with these labors for binding and cracking or bending the steel rods, blacksmith is required, second class. For helping the blacksmith, mazdoors are required. And next one, centering works and shuttering work, carpenter is required and mazdoor is required. These are all three types of labors are required. Okay, general labors for constructing and bending and shuttering. You have to keep in mind while calculating the rate analysis for RCC works. Now we'll go to the calculating the clear cut data. Okay, so item number already decide. First one, materials. In this materials, and next one, so first one is cement. I got it as 2.20 cubic meter. Am I right? And sand I got 4.40 cubic meter, and 20 mm ballast, 8.80 meter cubic. In the market we don't have any rate for cement in cubic meter. So for calculating meter cubic into kgs, I mean in market it available 50 kg cement bag. These calculations are already explained in the previous problem. Now directly I am going to calculate for 2.20, 64 bags. 64 bags is required. For 2.20 cubic meter, 64 bags is required. So in the previous problem I explained how to convert this meter cubic cement into the kgs, and after that kgs to bags I already explained. Okay, so you just go through that video, you'll get the data. Now the rate of cement is 330 rupees per 50 for bag, sorry, 330 rupees per bag, and this is a bag cost. Okay. And next for sand, 1800 rupees per cubic meter, and the stone that is 20 mm aggregate, we can, this is 2400 per cubic meter. These are all rupees. Okay. Along with this cement, sand, 20 mm brick, ballast, there is one more material is there, that is steel. Mild steel or HYSD steel. Now I am considering mild steel here, and the 1% I already calculated, clear the data, 7.85 quintal. 7.85 quintal quantity is required, and the rupees for steel 4200 rupees per, it is not cubic meter, and this is the quintal cost. Am I right? This is the quintal cost, and this is 330 rupees, 1800 rupees, and 2400 rupees, and this is 4200 rupees. How I get these values? As per SSR or SOR, schedule of rates or standard schedule rates, you can call it as. So APSOR or APSSR, you can take these values, but now I am considering these rates are textbook rates, that is BN data, textbook name as BN data. These rates are BN data rates. Now the cost is 21120, and this cost is, this is 330 into 64, 1800 into 4.40, and 2400 into 880, like that we have to calculate. And this is 7920, 2120, and last one is 32970. Along with this, some binding wire is required for binding the steel. Okay, so this is we have to bind this is we have to take 1.5 kg approximately. We have to take 1.5 kg, and this is 65 rupees per kg, and this value is equals to 97.5. so the total value of the materials is 8322.5. this is the total cost of materials. Okay, now we'll calculate the labor cost. Now three different labors are there, normal for constructing. So first one, head machine, so half number quantity, and the rate is 425 rupees per day. Labors we have to calculate per day. Next, and the cost is 212.50. and machine, so I am considering the three numbers for machine. I already discussed. Machine cost is 400 rupees. So no one will come for nowadays 400 rupees, and I'm saying this is the textbook concept. 200 rupees, sorry, 1200 for three numbers it is cost. And for Mazdoor, so for Mazdoor I am considering 12 numbers, and the Mazdoor cost is 250 rupees per day, and the total cost is 3000 rupees. And coolie, I am writing coolie here, 20 numbers, and the rate for coolies are 230 rupees, and here the 20 numbers, and the value is 4600 rupees. And the last one is Bisti, his water boy. 6 numbers are required, and the value is 250 rupees, and it will be is equals to uh, 230. For Bisti is also 230. Now it will take consider, final value is 1380. And for Sunrise, it is an Sunrise. And for Sunrise, so it is as approximately I am taking lump sum, it is lump sum rate 250 rupees, and this one is also 250 rupees. Finally, and the final rate of this labors are 10642.50. This is the rate of the to construct this particular work. Now second type of labors are for bending and crankings. For bending or cranking, labors are required. One is blacksmith. These are second class blacksmith. 8 numbers are required. I already discussed 8 numbers. 300 rupees per day. So per person we can call it as whatever it may be. For helping the blacksmith, Mazdoor required 8 numbers. So the Mazdoor cost is 250 rupees. And the last one is for every labor having some lump sum, because for every labor is some wants some tea, coffee, whatever it may be, snack. So that's why I have to add the Sunrise. We can call it as Sunrise, and this one is called as a lump sum. So this is a lump sum. I am taking 100 rupees, and the cost of these labors are 2400, and this is rupees 2000, and this is 100 rupees, and the total value will is equals to 4500 rupees. Okay, now and the last type of labors are carpentering and shuttering work and shuttering works. So carpentering and shuttering works, first of all we have to consider the timber flanks for supporting. So approximately I am taking, this is a lump sum I am taking, it will be equals to the 1500 to the 2000, whatever it may be. Now I am considering 1500, and this is also 1500 rupees. Now second one is carpenter, second class carpenter. Second class. Now 10 numbers are required. So each person cost is 10 numbers, and 10 numbers are required. 280 rupees, no sorry, 300 rupees carpenters are. And third one is Mazdoor, and Mazdoor also 10 numbers, 220 rupees. And the last one is not lump sum here. For carpenter there is some nails also required, okay, for hitting all those supporting. So here lump sum you can take, so 200 rupees. And last one is Sunrise, this is also lump sum. I am taking 100 rupees. So for calculating, this is 3000 rupees, 10 into 220, 2200 rupees, and this is a lump sum. and this is a lump sum. Finally approximate it will come 7,850 rupees. Okay, these are all lump sum calculations, 200 or 100 rupees, whatever it may be. Now we have completed the all the quantities of labors along with along with cost also. Okay, now we'll summing up all the data. One is material cost, general labor cost, bending and cranking labor cost, and carpentering and shuttering cost. So it will be is equals to, so total material and labor cost, total, so total materials and labor cost is equals to 1 lakh 6,440 rupees when you summing of all this data. After this we have to add 10% for contract charges. Am I right? 10% for contractor charges. So in the previous problem also already explained. So 10% means 1000. So 1064 644, that is 10,000, sorry, not 1000. And after that 1.5% for water charges. So it will be is equals to water charges 1596.00. So this is the total cost of material and labor, that is 1,06,440 rupees, and add 10% for contractor profits, it will be equals to 10,000, and add 1.5% for water charges. And finally now I am calculating the cost. RCC works in beam for 10 cubic meter work cost is equals to 1,18,680 rupees. This work, this rate is in 10 cubic meter. When you calculate 1 meter cubic, it will be equals to 11,868, and this is 1,18,000, but for 1 meter cubic it is 11,868 rupees. Okay, this is the calculation of RCC works. So a bit different when compared to the previous one, because the two types of labors are adding here. Bending labors are added and carpenter and shuttering labors are added. In bending we can call it as the blacksmith, in carpenter we can call it as carpenter second class. So like that we have to add. So very easiest problems, these are all rate analysis. So we have to remember the standard concepts. One is how to calculate the quantities, and how to what is a one density of steel per cubic meter. So when you remember all these things, then only you can easy to understand and easy to calculate the rate analysis. So now you tried in home one problem, same work in column 1:1.5:3. Okay, same concept you can take as same labors, even the same cost also, no problem. Only the material will be changed, that is steel material will be changed. Here we considered in the beam as 1%. Now steel will be equals to the 2% or 2.5%, your choice. So in the starting I explained 1 to 5%. So if you take 2.5%, no worries. If you take 2% also, no worries, but don't take 1%. Okay, tried either 2% or 2.5% with the same labors, no problem. Okay, so thank you. In the next video, so we'll go to the how to calculate the brick wall, okay, brick masonry works. Okay, thank you.